Man, take a look at this stuff. Isn't this pretty cool? If you would see that this part here is the eye of a needle, like a real needle, not like a blown up needle or anything. This artist, Willard Wiggin, makes these amazing creations within the pin, the eye of a needle, or at the top of a pin. Let me see if there's one. Look at that bicycle. Isn't that awesome? Or motorbike. That's pretty cool. Check this one out. This is at the top of a pin. He was on Conan O'Brien. I'm sure you guys don't stay up for that. And also on, what else was he on? He did a TED Talk. Pretty cool stuff. Today we're going to talk about stuff that deals with the idea behind some of his art. We're going to deal with scale drawing, scale models, and just the whole concept of making things smaller or larger than their actual size. Obviously, people aren't this little, but he made them super, super tiny. So if you want to check him out, you can check him out, Willard Wiggin, somewhere online. And as I said, he did a TED Talk. But let's check out our lesson for today. So in this section 6.6, chapter 6, we're dealing with scale model. Let me show that slide real quick. We're dealing with scale drawings and scale models. So we're going to talk about scale drawings and scale models as one concept. So I have them both as the same. And really it's the art or the process of drawing something or creating something, creating a model of something larger than the actual size or smaller than the actual size, like as we saw in the example with the artist. The next concept that we're going to talk about is a scale, is scale, which is basically, and when we talk about scale, we usually do it one to something else, and we'll talk about that in a minute. So let's say I drew I don't know, let's say I drew something that was 1 yard. Let's do yard here, as 1 foot. So for each yard, I drew it as 1 foot. That would be a scale. So I could write it as 1 foot to 1 yard. And we also know that we can write ratios like this as 1 foot over 1 yard. All right. So this would just be a scale. Now a scale factor is when I can take my 1 foot to 1 yard situation, right? And the key here is have it in the same units. So how do I change yards to feet? Well, simply put, my 1 foot would stay the same, but my 1 yard would turn into 3 feet because we know that 1 yard is equal to 3 feet. And then since I have the same units, I can kind of cancel those out. So the one artistic piece that I created that was 1 foot to 1 yard, 1 actual yard, I can say that it has a scale factor of 1 to 3. And I can write that as 1 to 3 or 1 to 3 like that. So scale and scale factor are very much related, but scale factor is when we actually take off the units. We make sure the units are the same. We take off the units and we write it without the units, and we call that the scale factor. Let's take a look at the first example here. So in this problem, we're going to be determining the scale. And so we remember that scale is just trying to figure out what to what we're dealing with. So suppose the model of a dragonfly has a wing length of 4 centimeters. So this is the model. If the actual length of the dragonfly's wing is 6 centimeters, you know what's the scale of the model. So here's what we do. We do 4 centimeters to 6 centimeters, right? And what I can do is, given our skill at solving ratios before, I know that I want to compare 1 centimeter of the model, the top part is the model, to, I want to figure out what the comparison of the model is to the actual figure. So I'm going to use x here, x centimeters, because I've got to figure out that ratio. And we know we can cross multiply to do this. 4 times x is going to give me 4x. 6 times 1 will give me 6. I'm going to divide both sides by 4 in order to figure this out, and I get that x is equal to 1.5 centimeters. So my ratio in this case, my scale happens to be very similar to my scale factor because they are in the same units, but the scale is going to be 1 centimeter to 1.5 centimeters. And I can write that in this way, or I could also write it as 1 centimeter to 1.5 centimeters. Like that. Both are fine. All right, let's take a look at example 2. In example 2, This is find the actual measurement. So here we have what is a blueprint of a skateboard ramp. And in the blueprint drawn, the length of the skateboard map, I'm sorry, the length of the skateboard ramp is 11.4 inches. If the scale of the blueprint is 1 inch to 6 feet, what is the actual length of the ramp? So what I like to do is set up my proportion, really, like I did in the last problem. I'm going to set up a proportion, and the proportion will be blueprint. I'm just going to write the word blue P with the period there over actual, right? And we are given a rate. We know that there is 1 inch to 6 feet. Now, since we're not in this problem asked to find a scale, I'm going to leave it exactly as it is. If I were asked to find a scale, I'd translate my feet into inches and do a 1 to, a 1 to something ratio, but that's not what I was asked to do. I'm just going to find this other value. So 1 inch of the blueprint is equal to 6 feet in the map, and then so of the actual ramp. And so I'm going to do 11.4 inches, right, is to X amount of feet, because that's what I need to figure out. I got to figure out how many feet is represented by these 11 inches. Hopefully this makes sense. Look, blueprint to actual, blueprint to actual. If you want to pause me here and calculate it and see if you get it, surely you can use the calculator. I'm going to pause it for a second, and I'm just going to pop up with the answer. So pause now. Hopefully you got it. We cross multiplied as we usually do. 11.4 times 6 is going to be 1 inch times x feet. So I end up with 1x over here, which is quite convenient, is equal to 6 times 11.4. And when I do that, x is obviously equal to 68.4. Since we were looking for feet, we got 68.4 feet, which is quite a long skate ramp. All right, let's look at another example, guys. In this example, we're going to construct a scale drawing based on some information. So Lila is painting a mural on a wall that is 18 feet long and 18 feet long and 12 feet tall. Make a scale drawing using 1/4 of an inch for every 3 feet as the scale. So what I'd like to do first is do a little bit of calculations. And those calculations will deal with translating the actual picture into the scale that I'm looking for. So you know that the model that we're going to draw, the model drawing, is going to be compared to the actual, right? And we're given that 1/4 of an inch is the model, and then 3 feet is the actual situation, is the actual wall. So let's translate the first dimension. We were given the 8 feet long wall. So then we know that the model is what we're trying to figure out. We're trying to figure out how many inches is that in terms of the model, and we're going to put 18 feet. I think I may have said 8 feet, my bad. 18 feet here. We can cross multiply. We could also, I know some of you are looking to say, oh, it's so easy, 3 times 6, I'm just going to multiply this. I say, well, we're going to do the thing. We're going to cross multiply, use that skill, and get our answer. So when I do that, I get 3x, that's these guys multiplied, times these guys, is going to give me 18 times 1/4. I'm going to make sure and put a dot there so it's not 18 1/4, it's 18 times 1/4. When I multiply 18 times 1/4, I end up with 4.5, so 4.5. And now I need to go ahead and solve this, so I'm going to divide both sides by 3. And when I do that, I get that x, or the model drawing, has to be 3 goes into 4.5. If you think about this, is how many times does 3 go into 45? Right? 3 goes into 45 15 times. The answer to this is 1.5. Of course, I'd let you use a calculator if you need to, but I don't think you need to. And so we have 1.5 inches would be the length of the would be the length of the wall, and the height of the wall we're going to calculate in the same way. So I'm going to actually slide down, give ourselves some more room. Maybe I should make this a little bit smaller. I'll see if I can shrink this a little bit, get it out of the way a little bit, and then all right, that's kind of cool. So we'll do that, and then we'll do very similar thing over here. We're going to do model. I'll just use MA for actual. The model is 1/4 of an inch to 3 feet. That hasn't changed. But what we're translating is the 12 feet, the height of the wall, and we'll do the same thing. Of course, you can pause me and see if you can calculate it on your own. So we'll get 3x is equal to 1/4 times 12. 1/4 times 12 is going to give me 3. So 3x is equal to 3. That tells me that x in this case is equal to 1. So x equals 1 means 1 inch for the width. So again, let me make this a little bit smaller. Almost to the assignment, friends. You see it down there. We're almost done. If I make that smaller so my work is tiny, I can hold on to that. You know I don't have a ruler on this thing, so I'm just going to pretend like I'm doing this. So the length of my wall will be 1.5 inches, which I just drew there with my measuring tool. Just kidding. And then the height will be 1 inch. And then so this is a scale model of the wall that 1.5 inch that Lila is drawing or painting in 1 inch. Voila. So that's how you do it, except you'd actually use a ruler where I didn't get it. All right. So my friends, here's your assignment. Make sure if you need to review the video, watch it again. Make sure it makes sense. I know some of the concepts seems a little bit strange. Try the problems. I cannot wait to talk to you tomorrow and make sure that we can work on this stuff together. I'll talk to you soon. Bye-bye.